Assalamu alaikum. I am Muhammad Tasbir Karim. Welcome to Tasbir's math tutorial class presented by Muhammad Tasbir Karim. Today we are going to solve a very important theorem, Pythagoras theorem. In class 8, it is very important and very common in the exam paper. So in chapter 9 we will get it. So here we are just going to prove it, how Pythagoras theorem, what is Pythagoras theorem, how it's come. So all the things we will just discuss here. So before Pythagoras theorem, we have to know something we learned already, but here we just revise again. That is, what is right angle? So we know that the angle which is measures 90 degrees is called right angle. Here is a diagram ABC, and that is 90 degree. I think it is very known to all. Then what is right angle triangle? What is right angle triangle? The triangle in which one angle measures 90 degree is called right angled triangle. So here is a diagram. This is a triangle. You can see one of the angle is 90 degree. So this angle is called right angle triangle. So in this right angle triangle, we have to observe there is a biggest side or opposite side of the right angle of a right angle triangle is called hypotenuse. So there are two things. One is the biggest side of a right angle triangle, or the opposite side of the right angle is called hypotenuse. By these two way, anyway, you can find out which one is hypotenuse. It is very necessary to know which one is your hypotenuse. So now the question, who is Pythagoras and how it's come? So in 6th century BC, Greek philosopher Pythagoras discovered a special property of right angle triangle. This property of right angle triangle is known as Pythagorean property. It is believed that before the birth of Pythagoras in Egyptian and Greek era, this special property of right angle triangle was in use. So we understand that is Pythagoras is a Greek philosopher, and he just his lifetime is just around 6th century BC. And what he did, he just find out the property of right angle triangle. But before that, Egyptian and in Greek people are using this property, but Pythagoras just is discovered and just provided for in writing way or other way that we can get it in right now. So now the question is, what is Pythagoras theorem? So in a right angle triangle, the square on the hypotenuse is equal to the sum of the square on the two other sides. Again, in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on other two sides. So here is the right angle triangle, and in this right angle triangle, we can say AC is your hypotenuse, and that's square is AC square. Look at here, AC square. And what is the other two sides? AB and BC. So AB square plus BC square. So this is actually in the alphabetical way, this is the theorem of Pythagoras, and this is the statement of Pythagoras. Again, look at it. In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the two other sides. So you have to memorize it before you are going to solve it, right? So just memorize. Okay. Now Pythagoras theorem. So look at it. Here is a right angle triangle. I can name it ACB. So let the triangle ABC, C is the hypotenuse. So here AB, in short form we just write it C, that is the hypotenuse, and A and B be the two other sides. A and B, these are the two other sides. It is required to prove that AB square, that means the hypotenuse square, equal to AC square plus BC square. So that means AB, just we writing instead of AB, C square, AC, A square, BC, B square. So is that clear to you? This is called proposition. and before just theorem we have to write it very much carefully. Sometimes you will get the question will not by taking A, B, C. It could be P, Q, R. It could be X, Y, Z. It could be M, N, O, or other alphabet also. So you have to be very careful of writing these alphabets here, and you have to write the question which one is asking to what theorem. You have to be very much careful about that. But you can let these alphabets C in the hypotenuse, A and B small font by the other two sides. It will help you to solve the problem. Now, for you know that solving a theorem sometimes we have to construct. So here is the construction. Draw four triangles congruent to triangle ABC as shown in the figure. So look at it. I am just drawing the similar triangle like this one here. Another one, the same type of triangle here you can see here, and another one here. So now it's a complete, you can look at here, it seems to be a square. Is that correct? If it is a square, we can call it square. So draw four triangles congruent to triangle ABC as shown in the figure. So here is an ABC triangle, and the similar four triangles are drawn as like as the figure. Okay, is that clear to you? Now we are going to the proof part. So here is the proof. Here is the diagram you can see here. So you have to need to draw this box. It's my suggestion. You'll just follow the books what is given to you. Okay, the way they are solving, that is maybe it could be helpful for you. So here is the steps and justifications. So look at here. Where is the box or the square inside of this one? It's vanished. Now you can see the thing in outside, that is actually square. And what is the length of this square? In one side you can see if it is length is A and it is B, then in total this side is A plus B. Similarly this one is also A plus B, A plus B, A plus B. So it's a square whose length is A plus B. So the larger region is a square with area A plus B whole square. We know the area of a square is what? Area of a square is side square. So what is the length of this side? A plus B. So its area will be A plus B whole square. So again the larger region is a square with area A plus B whole square. So here is the justification that the length of each side is A plus B and the angles are right angles. So it is a square, and we can call the square region, and its area is what? A plus B whole square. Is it clear to you? Okay, I'm going to the second part. Look again the diagram that I've drawn in the construction part. Now look another magic. Wow, the outside box is gone, the square is gone. But look in the inside, that is also a square. What is the length of this square? That is C. So we can call it smaller. Inner is smaller, just quadrilateral. It is also a square with area C square. So like the other one, that is the area of the square is side square. Its side is what? C. So its area is C square. Same things I'm just writing. The length of each side is here C. Do you understand clearly? Okay, fine. Now again the box is here. You can see here. Look at it. 1, 2, 3, 4. 4 right angle triangle, right? 4 right angle triangle. Each one have a right angle. So and a square inside, inner small square, right? So the bigger one, if you break it, you will get a small square, inner small square, and 4 right angle triangle. So we can write from the figure the area of the larger region, that is the whole region, is equal to the sum of the areas of 4 triangular regions and the area of smaller square. Again, look at it. The area of the larger square is equal to the sum of the areas of 4 triangular regions. So larger region is equal to sum of 4 triangular region. How many? 1, 2, 3, 4. And the area of smaller square and area of smaller square. So if I break the larger square, I will get 4 triangle and 1 small square. So what is the area? Look, the larger square area is a plus b square. We get it in step 1. And 4 right angle triangle, this is the area of one triangle, half into base into height. That is, this is your base, this is your height. For each of them you will get the same area, that is half into base into height. That is the area of a triangle. And how many triangle are there? 4. And the small square c square. So I think you understand from this above. From this above we just get it. Now the whole square formula, you know that a square plus 2ab plus b square, and if you simplify it, it will be 2ab plus c square. Now you will get, if you just simplify it, 2ab and 2ab gone, so c square equal to a square plus b square. So we can write ab square equal to ac square plus bc square, and that is the proof. So do you understand? Again we can see and together. Look at here, this is your diagram. Okay, what I did, let in the triangle ABC, C is the hypotenuse and ABB the two other sides. It is required to prove that AB square equal to AC square plus BC square, that is C square equal to A square plus B square. Construction: draw 4 triangles congruent to triangle ABC as shown in the figure. Now the proof steps, that is, first one, the larger region is a square with area AB whole square, so it is whole A plus B whole square. There the length of each side of is A plus B and the angles are right angles. The inner small square is also a square with area C square, and the length of each side is C. And from the figure, the area of the larger square is equal to sum of the areas of 4 triangular regions, and the area of a smaller square is that a plus b whole square equal to 4 into 1 by 2 into a into b plus c square, or a square plus 2ab plus b square. The formula of whole square is written here. If you simplify it, you will get 2ab plus c square. Now if you just calculate here 2ab and 2ab same part in the both sides, you can remove it and you will write c square here and a square plus b square here. So what is c? You just replace it by the alphabet ab, that is, you let it at before, and a, that is ac, and b for bc. So ab square equal to ac square plus bc square, and it is proved. I hope you understand very clearly. Thank you for watching this video. Hopefully in your JSC examination you will do this answer very quite well.